Okay, so let's start off with our precipitation reactions. So, precipitation reactions are very, very easy. Precipitation, neutralization, and gaseous will all have the same general equation. Okay? It is an A, B plus C, D. And what you're going to do is that you'll always write the cation first. That's the atom, the ion with a positive charge, then the anion, then the cation, anion. So you remember from nomenclature that we always write the cation first. And the way to remember that is that they say that girls are catty. Don't say that. I mean, girls are not catty. But they say girls are catty, and they should go through the door first. I know a lot of catty men, okay? Anyway, think of it as two couples at the bar. So one couple, the girl, the cation, says to her boyfriend, B, the anion with the negative charge, hey, that dude over there, D, looks really sexy. So I want to hang out with him. So she wants to swing. Professor Wall doesn't do that. All right. And then C says, okay, then I'm going to take your man. And so they swap couples. Isn't that nasty? Anyway, so A goes with D. And who will you write first? Obviously C, because C is the cation. C will go with B now. So swing it, baby, is how I like to say it. And that'll be for neutralization, gaseous, and precipitation reactions. So you have a cation, anion, anion. Now, the thing with precipitation reactions, and really with all of them, I want you to read your solubility table. That is in your syllabus, and you know I give this to you on every test and every quiz. So when you're going to look at your products, always analyze what's going on with that solubility table. If AD is aqueous and CB is solid, yes, you have a reaction. If AD is solid and CB is aqueous, yes, you have a reaction. But if both AD and CB are aqueous, then that's no reaction. So that's all you have to do after you reach your solubility table. All right, let's do some examples and see how it works. Here's an example of a typical precipitation reaction. Let's say barium nitrate aqueous is placed in a beaker containing some sodium sulfate, aqueous. So the very first thing you have to do is know your nomenclature. If you don't have that nomenclature down, we got a problem, a big problem. So barium nitrate. Barium is a 2+ charge, and the nitrate, as you know, is a -1. So you will need how many total nitrates to make the formula barium nitrate? You need 2 of the nitrate ions. And when you look at sodium sulfate, sodium is a +1 charge, and the sulfate is a 2-. So how many sodium ions will you need? You're going to need 2 of those. So let's put it all together and swing it, baby. All right? So here we have barium nitrate, written correctly, aqueous, plus some sodium sulfate, written correctly, aqueous. Identify your A, your B, your C, and your D ions. So this is my A, the barium ion. The B will just be the nitrate. Don't take that subscript. Then your C is going to be your sodium ion, and your sulfate keep that polyatomic ion together, that is your D. Then you're ready to what? Swing it, baby. And when you swing it, baby, what you get is barium sulfate. You don't know the charge yet. And some sodium nitrate. Don't know what the state is yet. This is real important. I tell students just say the name of the actual products once you swing them and write it correctly. Never change your charges. Just swing it, baby, and write it correctly. It is much easier to balance it right here because it's one barium, one sulfate, one sulfate. But I have 2 nitrates, so I better put a big coefficient of 2 in front, which then also balances my sodium ion. So now we're completely balanced. Now let's look at how do we look at that solubility table. I want you to look for the bold words. And when you read that, it says to you nothing about barium in bold, but it does talk to you about the sulfate in bold. And it says anything with the sulfate is soluble, exceptions will be with the barium. So you will say this is insoluble, which is a solid. That is your precipitant. Then when you look at sodium nitrate, it also tells you that anything with group 1A will always be soluble. Also, anything with a nitrate is always soluble. So if it's soluble, you're going to call that aqueous. Now, this is the process you will use whenever you have a precipitation reaction. But you have to have your solubility table right there with you. And if you have it with you, just learn to read it, because reading is fundamental. Thank you.